Hello everyone and welcome to Chapter 7, Equations. We're going to look at Lesson 1, Equations, on page 513. As you can see, the word equation looks like the word equal to, right? Equal, which means the same, right? An equation is a mathematical sentence showing two expressions are equal. An equation contains the equal sign to state that one side is the same as the other side. So let's look at the definition. An equation is a mathematical sentence showing two expressions are equal. I didn't change anything really from the statement in it. An equation is a mathematical sentence showing two expressions are equal. You see? I just copied it there. Then what is an expression? Well, an expression could be like 2 plus 4 minus 3, right? It's a combination of numbers and operations like addition, subtraction, multiplication, division, which might contain variables, which might contain letters or values that we don't know. Okay, let's give an example of an equation. An equation needs to have the equal sign. The equal sign is saying that this side of the equation is the same as this side of the equation. And I know that 5 plus a variable, plus a number, is going to be the same as 13. Okay, that's an equation. An example of an expression. Again, the same thing. It could be the exact same, but an expression, boys and girls, just doesn't have the equal sign. Okay, so it would be replaced by another operation. But let's just write one that looks similar but not the same. I could say 5 plus x minus 16. You notice that this doesn't have an equal sign. It's just an expression or a number sentence like we used to do in elementary school. Okay, how are an equation and an expression similar? How is this similar to this? Besides the fact that I use 5 and x in both of them, but besides that, how are they similar? Well, as you can see, they both contain numbers. You see 5, 13, 5, 16. And they both contain operations, plus, plus, minus. And they both may contain variables. Here we have an x and here we have an x. Okay, that's how they're both the same. They're numbers and variables with operations. How are the equation and expression different? I think you already know, right? Well, an equation has an equal sign, as you can see here. This is telling me that this side is the same as this side. So really we have two expressions. But an expression does not. This expression does not have an equal sign. It's not telling me that this is equal to something else. You see? Okay, let's try the real world link. Shopping. Anna bought a package of 6 pairs of socks. She writes the equation below to find how much she paid per pair. Circle the solution of the equation. So she bought 6 at a price that she doesn't know. Okay? 6 at X price. 6 times X, right? 6 pairs of socks at, if they're each $1, it'll be 6 times $1 times 1. So it'll be 6. Those she paid. But she actually paid $9. So 6 times something is $9. These are equal. Remember, this side has to equal to 9. What number do I multiply 6 into so I can get 9? Because remember, it's equal. This side is the same as this side. Okay? Well, when I multiply 6 times 1, I'm going to get 6. Correct? 6 times 1, I'm going to get 6. And 6 times a half, I'm going to get half of 6, which is 9. As you can see right there. If I were to use distributive property and break it up into a number, because I know that if I multiply 6 times 2, I'm going to get 12, so it can't be that. And 6 times a half, remember this is a half, 0.5 is a half, I'm going to get 3, because I get half of the number. So this is the only one that makes sense. But if you actually did it like this, where you do 6 times 1, okay, you're taking this 1 here, and you're separating this number. And you also take 6 again, your 6 here, right, times a half, times 0.5. Okay, here you will get 6 plus 6 times a half is half of 6, which is 3. And there's your 9. Okay? Okay, as a key answer, when I check your homework, I'm going to check that you have also written all of this right here. There's some space there on the side for you to do it. Please make sure that you copy this down to show your process, and make sure that you circle the correct answer. Okay? This is a key answer, boys and girls. I will be looking that you also showed your work and you watched the video. Solve addition and subtraction equations mentally. When you replace a variable with a value that results in a true sentence, for example here, if you replace this variable with the number 7 so that you have 2 plus 7 is 9, and it makes it a true statement, 9 is 9, 9 equals 9, then you can say you solved the equation. So if you're ever given a question like this, okay, an equation like this, and you're being told to solve it, it means you're looking for the value of the variable. That value for the variable is the solution of the equation. Now there's two ways we can do this, boys and girls. I know that they're telling you to do it mentally, but there are a couple of ways. One simple way is to make sure that whatever you do to one side of the equation, you must do to the other. And we want to isolate the variable. Okay, let me make this nice and big here. You want to isolate the variable, which means you want to leave this all by itself on this side of the equation. So we got to get rid of the 2. Okay? So if we're going to get rid of the 2, we have something that looks like this. We have 2 plus x minus 9. Let's get rid of the 2. In order to get rid of the 2, I have to subtract the 2. Am I right? I have to subtract it out. So that now it's 0. Okay? 2 cancels out the 2. So all I'm left with on that side is the x. But if I subtract a 2 from this side of the equation, I have to do it from this side of the equation as well, so that this remains true. Whatever you do to one side, you have to do to the other side so that it continues to be equal. And now if I subtract 2 from the 9, okay, I get my 7. So x equals 7. You see that? It's right there, it's 7. That's one way to do it. The other one is to isolate the variable and invert the operation. I'll show you that example later. Here they're showing you how to do it mentally through guess, check, and revise. The method of guess, check, and revise. We have 3 plus, the question is actually a number plus 7 is 11. Well, you guys know that all you have to do is add 4 to 7 so that you can get 11. You know that, so you can do it mentally. But if you're just doing guess, check, and revise method, you would do this. You would try the 3 first, and you notice that you'll get 10. 10 is not the same as 11, so it doesn't work. And then if you try 4, you'll see that 4 works because you get 11 is 11. If you try 5, 12 is not 11, so it doesn't work. This is guess, check, and revise. So the solution is 4. And then a number minus 7 is going to give you 3. A number minus 7 is going to give you 3. If you try 10 minus 7, yeah, that'll give you 3. That's the other way to do it. Now, remember, boys and girls, here I'm going to show you the other way to do it, isolating the variable and inverting the operation. So I have g minus 7 equals 10. Over here, I'm subtracting a 7. I want to isolate the variable. Isolate it means leave it alone on that side of the equation. You see, there's no longer a minus 7. What do I do with this minus 7? Well, I bring it to the other side of the equation because I want to leave g all by itself on that side of the equation. But if I'm going to drag it across the equal sign, I have to invert it. It means I have to do the opposite operation. On this side, it's being subtracted. That means if I do the opposite of subtraction, I will have to add it on this side. So now I have 3 plus 7. And g equals 10. Am I right? There it is, right? Okay, here's a word problem using the guess, check, and revise strategy that we just talked about. The total cost of a pair of skates and knee pads is $63. That's the total cost. So we know that's my total. We can write it as, that's my total. It's 63. That's what it equals. The skates cost $45. Use the guess, check, and revise strategies to solve the equation 45 plus k equals 63. K is the cost of the knee pads. So I know I have $45 plus my knee pads. And I don't know what I paid for the knee pads, but I know that my total was $63. I only saw the price of the skates. Okay, I only saw the price of the skates. Well, we can use guess, check, and revise. 45 plus a number is 63. Or, boys and girls, let's isolate the variable and invert the operation. Look at that. We invert it. Why am I subtracting 45? Well, because on this side it's being added. On this side it's being added. So I'm going to take it to this side and subtract it. It would be the same way, boys and girls, if we were going to subtract it from both sides. Let's say I had the equation. Let me see if I can just delete that one. Okay, let's say I had the equation like this, and I want to isolate my k, right? So I subtract the 45 from this side. So minus 45, right? So now I only have k left. If whatever I do to this side, I must do to this side. So again, it's 63 minus 45. So it doesn't matter. And 63 minus 45 is 18. Okay, so remember I subtracted 45 from this side, so I have to do the same thing on the other side. And there's the other way to do it.